You know all those apps and websites we use every single day without a second thought? Ever wonder how they actually get built? Well, it's a lot more than just a bunch of people typing code. There's this hidden architecture, this whole discipline, that turns a chaotic idea into something that actually works. And today, we're going to pull back the curtain on exactly that: software engineering.
Okay, so let's dive right in. But we're not going to start with a solution. Nope. We're going to start with a huge, industry-shaking problem. See, as computers got more powerful, our dreams for what software could do got bigger and bigger, and that led to what everyone in the field now calls the software crisis.
I mean, it's the question that haunted the early days of computers, and let's be real, it still keeps developers up at night. How can building something you can't even touch, something made of pure logic, go so unbelievably wrong? We've all seen it, right? Buggy video game launches, massive airline delays because of a computer glitch, your favorite app just going down for hours.
And get this, the scale of the problem was just staggering. Some reports showed that 70% of projects were failing. 70! And we're not talking about small delays. We're talking about total, complete, pull-the-plug failures. It became clear this wasn't just bad luck. Something was fundamentally broken in how we were trying to build this stuff.
And the stakes? Oh, they are incredibly high. This isn't just about your game lagging. We're talking about the NASA Mars Climate Orbiter literally getting lost in space forever because of a software bug. We're talking about banking systems messing up millions of dollars in transactions. And, scariest of all, medical machines giving patients fatal overdoses. This is serious stuff.
So here's the bottom line. As software started running our finances, our travel, and even our healthcare, the old way of doing things, just letting brilliant programmers go wild with code, wasn't just sloppy. It was becoming downright dangerous. Chaos just doesn't scale when lives are on the line.
So out of that chaos, a new idea started to form. What if we took the lessons learned from traditional engineering, the discipline it takes to build a bridge or a skyscraper, and applied that same rigor to building software? And just like that, the field of software engineering was born. Now, this official definition sounds a little dense, but it's got 3 killer ideas. Systematic just means having a plan instead of making it up as you go. Disciplined means you actually follow that plan. And quantifiable, this is the big one, it means you can actually measure your success. You can track costs, find bugs, and prove your software is reliable. It's about turning code from a messy art into a predictable science. Okay, that all sounds great in theory, but how does it actually work? Well, think about it like this. You would never, ever build a skyscraper without a detailed blueprint, right? Of course not. And it turns out, building complex software isn't any different. You need a plan.
And in the software world, that blueprint is called the Software Development Lifecycle, or just SDLC for short. The best way to think of it is as the master plan. It's the roadmap that takes you all the way from that first spark of an idea to a finished product that people can actually use.
And pretty much every roadmap has these same basic stops. First, you figure out what you're supposed to build. Then you design how you're going to build it. And notice, only then, step 3, do you actually start coding. After that, you test the daylights out of it, you release it, and, this is super important, you stick around to maintain it. This whole process is the direct antidote to that chaos we were talking about.
All right, so here's where it gets really interesting. Pretty much everyone agrees on that basic blueprint, but there are 2 totally different philosophies on how you should follow it. I like to call it the architect versus the explorer. First up, we have the architect. This is the classic old-school approach, and it's called the waterfall model. Think of an architect who plans out every single nut, bolt, and wire of a building before anyone even breaks ground. It's all about perfect, meticulous, upfront planning. And the name waterfall is perfect, because it's a one-way chip. You do step 1, then it flows down to step 2, then 3, and so on. You can't go back up. You lock in the requirements, finish the entire design, write all the code, and only then, at the very end, do you test the whole thing. It's super rigid, but it leaves very little to chance.
But what happens when you don't really know what the final destination looks like? Well, that's where the explorer comes in. This approach is called agile, and it's all about being able to adapt. Instead of one giant, perfect plan, you work in small, fast bursts, building a little piece of the project, learning from it, and then adjusting your path as you go. The whole philosophy of Agile is a huge shift. It basically says that having smart people talking to each other is more important than having a rigid process, that having a piece of working software is better than having 100 pages of documentation, and most importantly that being able to respond to change is better than blindly following a plan that might be wrong.
So let's just put them side by side. Waterfall, the architect, is rigid. Agile, the explorer, is super flexible. In Waterfall, testing happens at the very end. In Agile, it happens constantly. With Waterfall, you talk to the customer at the start and at the finish line. With Agile, they're basically part of the team the whole way through. Now, one isn't always better than the other. They're just different tools for very different kinds of projects.
Okay, so we've got these big, complex processes and these competing philosophies. But let's just pause for a second. What's the point of all this? What are we actually trying to achieve here? What does good software even look like?
And that sounds like a simple question, but it's actually really deep. Because if you don't know what quality looks like, all the process in the world is useless. It's about so much more than just making something that doesn't crash. Most of the time.
Well, it turns out there are a few key things that really separate the good from the bad. First, reliability. That's non-negotiable. Your ATM software can't just decide to crash mid-withdrawal. Then there's usability. Is it easy to use? If you need a 20-page manual to figure it out, it's failed. And then there's the unsung hero, the secret ingredient, maintainability. And if you're wondering why that's such a big deal, look at this number. A mind-blowing 60% of the total cost of software happens after it's been released. That's all the money spent on fixing bugs, adding new features, and just keeping the lights on. So building software that's easy to maintain isn't just nice, it's a massive financial decision. So, after all that, the crisis, the discipline, the different blueprints, what is the one big idea you should take away from this whole explainer? It really comes down to this one simple sentence. That app you love that just works perfectly every single time, that wasn't an accident. That wasn't just a stroke of genius. It was the result of a systematic, disciplined, and really thoughtful process. It wasn't just coded, it was engineered. So I'll leave you with a little challenge. The next time you're using an app and it's just smooth, intuitive, and does exactly what you want, take a second. Try to see past the screen. See if you can feel that invisible blueprint underneath it all. The careful planning and the hidden engineering that made that simple, perfect experience possible.